This is lesson 3.2, elimination. We're still going to be solving systems of linear equations, but this time we're going to learn how to do it without graphing. So last time we did graphing to solve systems of linear equations. Sometimes that was a little bit messy. It was kind of hard sometimes to see where the solutions were. So a better method is to use algebra to solve, and the nice thing about using algebra to solve is that you don't have to graph. So here's the first example. If I have 4x plus 3y equals negative 2, and I have x plus 5y equals negative 9, then I can see that if I were to multiply this bottom equation by negative 4, then it would cause the x's in both of my equations to be the same number but opposite sign. So for example, this equation is still 4x plus 3y equals negative 2, but now the bottom equation is negative 4x minus 20y equals positive 36. So now if I add this straight down, 4x plus negative 4x cancel each other out. That has eliminated the x. That's why it's called elimination. We eliminated one of the variables. 3 plus negative 20 is negative 17y. And negative 2 plus 36 is 34. So if I divide by negative 17, then my y value is negative 2. Now, I still have to find the x value, so I'm going to come back up here. And you can pick either of your, either equation that you want to. I'm just going to use the top equation. So I have 4x plus 3 times negative 2 equals negative 2. Remember that this negative 2 comes from down here where we knew y was negative 2. So 4x minus 6 equals negative 2. So add 6 to both sides. 4x equals 4. Divide by 4, and x equals 1. So without having to graph this at all, we have a solution of 1, negative 2. And it's an exact solution. We don't have to wonder if it's an estimate or if it's off by a little bit, because this is an exact solution. All right, let's try another equation. If I have this system of equations here, 3x minus 10y equals 10, 3x minus 7y equals 10, 6x minus 8y equals 8. This time, if I look at my numbers, I'm trying to decide, can I make my y's the same number, or can I make my x's the same number? If you look at this 3, I know that if I multiply by 2, it will give me 6. So I'm actually going to multiply this whole equation by negative 2, because I want it to be 6, but I want it to be the opposite of 6, so I want it to be negative. So when I distribute the negative 2, I get negative 6x plus 14y equals negative 20. That's from distributing this negative 2 into this entire equation. Now the other equation, 6x minus 8y equals 8, hasn't changed at all. Remember, I'm going to add going straight down. Negative 6x plus 6x cancels. The x has been eliminated. 14y plus negative 8y is 6y. Negative 20 plus 8 is negative 12. Divide by 6. And y is negative 2. Now I'm going to take that value, and I'm going to come back and I'm going to plug it back in to one of the places up here. So I'm actually going to use this equation where I have 6x minus 8y, but instead of y, we're going to replace it with negative 2, and that's going to equal 8. So 6x plus 16 equals 8. Subtract 16 from both sides. I get 6x equals negative 8. And if I divide both sides by 6, I get that my x is negative 8 over 6, which reduces to negative 4 over 3. So my solution is negative 4/3, comma, negative 2. Keep in mind, we graphed these before, and when we graphed them, the intersection is what gave us the solution. This is still going to be the intersection of our two lines. Okay, one more example. 3x minus 6 equals 9. Negative 4x plus 7y equals negative 16. Okay, this one's not so obvious. I have a 3 and a 4 for my x's. I have a 6 and a 7 for my y's, which there's actually missing a y. I just realized that's not good. That's a y right there. Okay, so I can't just multiply one of them, so it looks like I'm going to multiply both. Now this time I'm going to multiply by 7 on the top and 6 on the bottom, because that will make both of my y's become 42. The only reason I chose to do this with the y is just so that you could see that it doesn't matter if you multiply to eliminate your x's or if you multiply to eliminate your y's. So multiplying the first whole equation by 7 gives me 21x minus 42y equals 63. Multiplying the whole bottom equation by 6 gives me negative 24x plus 42y equals negative 96. And then we're going to add this straight down. So 21x minus 24x is negative 3x. Negative 42y and positive 42y cancel. 63 minus 96 is negative 33. Divide by negative 3. And your x value is 11. Now that I know the x value, I can come pick either of the original equations. It doesn't matter which one you pick. I think we will pick this bottom one. So we'll have negative 4 times 11 plus 7y equals negative 16. So to solve this, this gives me negative 44 plus 7y equals negative 16. I'm going to add 44 to both sides. So that's 7y equals, what, 28? Divide by 7, to sneak that in there. And I get y equals 4. So when I put my solution together, my solution is 11, 4. Okay, here's a problem for you to try on your own. Do this in your spiral, and it can be checked in class.